Assalamualaikum and greetings everyone. In this video, I will present on subjective answer marking system using keyword extraction. This study is conducted by Radin Arini binti Radin Muhammad Mokhtar and Ahmad Farid bin Najmuddin from Faculty of Computer and Mathematical Sciences, UiTM Perak Branch, Tapah Campus. This presentation is divided into 5 sections. The introduction, problem statement, methodology, design and implementation, and conclusion. So for the introduction, COVID-19 pandemic has driven learning institutions to perform online distant class or online distant learning (ODL), which the students and the lecturers will have to communicate through online platform. All the assignments and the examinations must be submitted online within the due date given. Due to overwhelming number of assessments and assignments during the ODL, lecturers are overburdened with the digital submission task, which all the works are submitted online by the students. During the online examination, subjective questions are compulsory for students to answer to get marks. Subjective examination means assessing answers which have descriptive, defined or explained types of questions. So for the problem statement, overwhelming number of digital assessment and assignments during online distant learning may burden the lecturers or teachers. It is time consuming where lecturer and teacher has to manually mark the student answer papers digitally. And then overexposure of computer monitor brightness may cause vision related sickness to the teachers or lecturers. Therefore, this web-based system aims to assist lecturer or teacher on marking a subjective or structured answers using keyword extraction technique. The system will help lecturer or teacher marks the answer digitally by comparing student answers with the answer scheme provided. This study uses the WLDLC method or Web Development Lifecycle method to develop the system. The WDLC is an organizational process of developing and maintaining website. There are 5 phases of the WDLC, which enables the complete designing process. So there are 5 phases here. So the phase 1 is planning, phase 2 is analysis, phase 3 design and development, phase 4 testing, and the last phase is phase 5, implementation and maintenance. So this is the system architecture of the system. The system architecture is divided into 3 different components. First, the candidate answer will be submitted and being processed to the data post processing. Then in the segmentation process, it will find the stop word and trace all the important data to be transferred to post processing such as function word removal. Then the document is tokenized. Next, it is a word extraction process where the keyword extraction would find the suitable method to use in find the keyword point and store it in the keyword domain database. The next process, which is the scoring part, that identify which keyword from the candidate answer that can be evaluated, their score from the keyword weight adjustment that is significant with the answer scheme. The noun phrases are scored and clustered, and then the clusters are scored. The shortest noun phrase from the highest scoring cluster are then used as the keyword. From the scoring part, the final candidate outcome can be shown in the result phase, which the end output of the system. So for keyword extraction, keyword and key phrase are useful in analyzing large amount of textual material quickly and efficiently. based on Siddiqui and Sharan 2015. Statistical approach named Rapid Automated Keyword Extraction or RAKE was used for keyword extraction process. RAKE is a keyword extraction algorithm that is extremely efficient, which function on individual documents to enable an application to the dynamic collection. It can also be applied on the new domains in easy way and effective in handling multiple kinds of documents, especially the type of text which follows specific grammar conventions. Okay, so this is the process flow of the system. First, the user will be greeted with a welcome page, and then the user will enter student answer, and then user will enter the reference answer. Okay, the suggested mark will be entered by the user. After that, user will click the submit button to go to the result page. The evaluated marks of answer will be shown. User can click go back link to check the next student subjective answer. Okay, so this is the example of a welcome page and main page. Okay, so in the main page, okay, there are columns or text fields for user to enter student answer, and then the reference answer, and also a little text box to enter the suggested marks. And then finally, in the result page, okay, the user will be prompted with the evaluated marks of the answer. Okay, in training phase, the process of training the dataset that will be utilized as the website backend is known as model training. But for this project, it does not going to be in the training phase because it is just using the keyword similarity to be compared with the reference answer or answer scheme, and it will be trained by using a method called cosine similarity. Cosine similarity measures the similarity between of the two vectors in an inner product space and be calculated using the formula. Okay, it determines whether two vectors are pointing in the same general direction by measuring the cosine of the angle between them. In text analysis, it is frequently used to determine document similarity where the value of cosine theta is in the interval of 0 and 1. Okay, so this is the example of source code to check the cosine similarity used in the system. So this is the result of 15 student answers. Okay. For the result, the marking system was tested using the student answer, okay, on their previous exam to observe how the system works. Okay, result from 15 answer papers shows the difference between manually marking and automated marking are within the acceptable range, with the highest of 0.5 mark difference. So for conclusion, this marking system is a machine learning project that applies the natural language processing using cosine similarity technique. The specific methodology for this project is web development lifecycle (WDLC). Since this project is a web-based system, in the testing phase, the system has achieved a great level of exactness, showing that this system is exceedingly accurate and ready to be used by the end user. This system is believed able to help in reducing lecturers' time to complete their marking tasks, and it promotes less error and mistakes, okay, reduce inconsistency marking and emotionally judgments. Okay, so the limitations of this system is the user need to manually enter the student's answer to the text form if the answer is written, if the answer is in the form of handwriting. Needs to expand the answer type form and improve the adaptive processing technique for each type of answer. Okay, so for the recommendation, to extract words from the student's handwriting so that it can be copied easily. Compile all subjective answers, mark in one time to reduce marking time. Categorize the answer, short or descriptive answer, and implement the program into existing web quiz or test platform to produce automated marks on students' subjective answers. Okay, that's all for now. Thank you for listening. See you later. Thank you.